here we have to evaluate an expression. Evaluate 2 plus the square root of 3 to the power of 5 plus 2 minus the square root of 3 to the power of 5. You could solve this using a binomial expansion. However, that would be quite difficult because there will be a lot of things you'd have to, there'll be a lot of roots, and you have to multiply and subtract a lot of things, and it will take a long time. So instead of using a binomial expansion to solve this, we're going to be using Newton's sums. Now, in order to use Newton's sums, we still actually need an equation. So how do we get an equation from this expression? Well, actually, you can pretend that 2 plus the square root of 3 and 2 minus the square root of 3 are two roots to a quadratic equation. So, if these are the two roots of a quadratic equation, we can use Vieta's formulas to make that quadratic equation. What is the sum of the roots? Well, 2 plus the square root of 3 plus 2 minus the square root of 3. The square root of things cancel out. The sum of these two roots, again, ignore this to the power of 5 for now. Just pretend that the roots are 2 plus the square root of 3 and 2 minus the square root of 3. The sum of these roots are 4, and I'm going to say that the sum is equal to a. So a equals 4. And the product is this is just 2 plus the square root of 3 times 2 minus the square root of 3. The product, when we multiply them together, is just 1. So we can make a quadratic equation out of this. By Vieta's formulas, we can have x squared, and then the linear term will be the minus of the sum, and the constant term will just be what the product is. X squared minus 4x plus 1. And we can equate that to 0. So the roots of this equation will be 2 plus the square root of 3 and 2 minus the square root of 3. And now we can actually use Newton's sums. Newton's sums tells us that if we want to find, let's say we have two roots r and s. If we want to find r to the power of n plus s to the power of n for some positive integer n, and in this case what we want to find is r to the power of 5 plus s to the power of 5, then what we have to find is a times r to the power of n minus 1 plus s to the power of n minus 1 minus b times r to the power of n minus 2 plus s to the power of n minus 2. This recursive equation right here is what what Newton's sums is for a quadratic equation. In order to find r to the power of 5 plus s to the power of 5, which will give us the value of our expression we want to find, we have to find r to the power of 4 plus s to the power of 4, and also r to the power of 3 plus s to the power of 3. And also, along the way, r to the power of 2 plus s to the power of 2, r to the power of 1 plus s to the power of 1, and then r to the power of 0 plus s to the power of 0. So instead of starting at r to the power of 5 plus s to the power of 5, let's start at 0. And by the way, for now, I'm just going to say that r to the power of n plus s to the power of n is equal to p of n. So it'll be easier for me to say it. So, and we want to find p of 5. But for now, let's start from 0. What is p of 0? In other words, the first root to the power of 0 plus the second root to the power of 0. Well, that's just 2, because anything to the power of 0 is 1, and when you add 1 and 1, you get 2. What's p of 1? P of 1. That is just r plus s, the sum, which in this case is just a. And then, let's see, what's p of 2? P of 2 is, well, now we have to use our recursive equation. P of 2 is equal to a times, in this case, p of 1, minus b times p of 0. Let's solve this right now. So a is 4, p of 1, what we just found is just a, so 4 again, and then minus b, in this case, is 1 times p of 0, 2. 1 times 2. So 16 minus 2, that's 14. P of 2 is 14. And remember, we have to get to p of 5, so it'll still take a while. P of 3 now is a times p of 2 minus b times p of 1. So a is 4, p of 2, what we just found, is 14, minus b, which in this case, again, is 1, b is just the product of the terms, which we found was 1, and then p of 1, which is, again, just 4. So we have 4 times 14 times minus 1 times 4. That is 52. We're almost there. P of 4 now is, again, 4 times p of 3, which is 52, minus b, which is 1, times p of 2, which is 14. And that is equal to 194. And this is p of 4. Let me just circle all the powers, sum of the powers of roots. P of 1, p of 0, 2, 3, 4. And finally, we are at p of 5. P of 5 is 4 times p of 4, 194, minus 1 times p of 3, 52. And when you solve this expression, you finally get 724. So p of 5, which in other words is r of 5 to the power of 5 plus s to the power of 5. Let me draw an arrow. And in other words is 2 plus the square root of 3 to the power of 5 plus 2 minus the square root of 3 to the power of 5 is equal to 724. And we have gotten this answer using Newton's sums for a quadratic polynomial. And we're done.